In this video, you're going to see a PowerPoint presentation similar to the one we gave the experts near the end of their 3-day meeting. We begin by explaining that we're going to give you 100 points and ask you to allocate them to some future possibilities. We tried to introduce them to the idea with an example. The example, as you see here, is asking them to allocate the 100 points over the likelihood that 3 different candidates will be elected. So everybody got a chance to practice on the types of questions that they were going to be asked. And by the way, I should mention that this was done after an elicitation exercise. Everyone was provided with the PowerPoint exercise, same one that you're using for this class, that gave them a chance to see that they were all in general overconfident. After we gave that political example, we gave them an actual example just to help them understand what was coming, and we asked the question that you see here: what were the main considerations in shaping your answer, so that they would get used to the idea of what we were looking for when asking questions like that. We told them that when it came to fish passage, we would be asking them the minimum number of fish that could pass in a year and the maximum number of fish that could pass in a year. And then we gave them 2 percentile values that enabled them to kind of break the curve, to give it some shape, or to skew it more toward the minimum or the maximum. And we spent some time with them explaining how to do that. We said there's no chance that the value will be less than your minimum and no chance that it will be more than your maximum. We gave them a percentile refresher and reminded them that they may have heard about these percentiles from standardized test scores or when they took their babies to visits to the doctor when they were infants. Then we presented them with an example. We asked how many total runs will all the Major League Baseball teams score in all the games played during the 2016 season. And then I explained how I came up with these estimates. I figured the number of teams per year, the number of teams in Major League Baseball, figured that there would have to be 2 teams at a time, so I took half the number of teams in Major League Baseball times 162 games to get the total number of games in a year. Then I multiplied that number by an average of 7 because I thought the average number of runs was probably between 7 or 9. And that gave me these 2 values that you see here. Then the purpose of this was to show people how you might use the percentiles to skew the data. So there's a 1/3 chance that the total runs will be between 17,000 and what number, and in my opinion, I thought it is much more likely that there would be 7 runs per game than there would be 9. So I placed the 33rd percentile relatively close to 17,000. Now we're looking for the next 1/3, and I thought there was a 1/3 chance that it was going to be between 17,700 and 18,900. So my 67th percentile was also skewed toward the lower end. What this is telling us now then is that there's a 1/3 chance that the actual number of runs would be in any one of these 3 intervals. We spent some time talking about that to make sure everybody was comfortable with these percentile values. Then we gave them an example. Here is the Brandon Road Lock and Dam and a vessel locking through it, and we asked them to estimate the number of commercial vessels that pass through Brandon Road Lock and Dam each year. Here was the worksheet that we gave them, and some sample values. Those sample values then were used to develop this cumulative distribution function. So we wanted people to see how the data that they were providing would be used. This is that same function when it's displayed as a density function. So this is basically saying that values near 3,300 in this range. These are much more likely than these values, which are more likely than these values. But the number line delineates that it would be between 1,800 and 3,300. And that's the number of toes that we were estimating here. So people again got to practice the technique using a value that was not going to be one of the ones that they would actually be asked. The number of barges, by the way, was slightly less than 3,000. We were asking for values that no one knows, and no one could ever prove that the experts were right or wrong, because the things we were asking are unknown. So we wanted help to understand what's possible. So we didn't want people to provide us with information. We wanted them to tell us how big the hole in our gap, our knowledge was. So we weren't asking anybody to fill that hole. Experts don't produce knowledge. What they do is they help to describe the uncertainty. And people, even experts, tend to suck at this. And so we spent some time with them trying to understand why they suck at this and to help them suck less at it. And this all came after the calibration exercise. So we looked at these sorts of heuristics, the shortcut rules of thumb that people use instead of thinking critically. Excuse me. So calibration, after we did the calibration exercise, we could conclude that experts are generally not well calibrated because they don't know what they don't know. After we did the calibration exercise, we found that most of our people were very much overconfident. Some of the problems that you run into with this overconfidence is because we use this anchor and adjust heuristic. People tend to begin with a value that's called an anchor. Then they estimate a minimum and a maximum by subtracting and adding an adjustment to this anchor. The problem is experts fail to make big enough adjustments because they're overconfident. And the solution is fairly simple. Don't begin with an anchor. We did not ask the most likely value. We didn't use an anchor. We used 4 different values here, and we consulted diverse experts. We were very careful to make sure that the experts had time to think first, well before the questions were asked. That's why they had the 3-day meeting, and they also had time in the elicitation itself. Sometimes there's motivational bias. People might want to influence a decision. They perceive that they're going to be evaluated based on the outcome, or they might suppress their uncertainty to appear more knowledgeable than they are. Sometimes the desire to work for one of the parties involved in the decision problem can influence them. They might have a strong position on a question, or they could be cockeyed optimists or perpetual pessimists. So we asked everybody to check their motives, and then to check them at the door, leave them behind. Once again, using multiple experts is one of the best ways to overcome motivational bias. There's availability as another heuristic. Asian carp seem more likely after we find one, and less likely if we have not seen one for years. Availability relies on examples that come immediately to mind. Availability of an idea is heavily weighted by the recentness of the information and the magnitude of the consequences. So we always tend to overestimate the likelihood of an airplane crash, for example, after seeing vivid video of the latest crash on the TV. And then if we've heard nothing for a while, we tend to underestimate these likelihoods. The solution would be to discuss this with experts. We would increase the number of examples that we would use. Representativeness is another heuristic that's used. People find a familiar event they believe to be comparable and assume the values will be similar. So that might be another species, a different set of barriers than the ones that we have in our waterway. They might use a field trial, an animation, or something like that as representative of what goes on in this particular example. What we see in small examples is what we expect to see in the large example. Belief in good luck and bad luck can influence representativeness. So we ask people to do the math. Once again, this power of diversity is important. By making sure people don't ignore base rates, the frequency with which things occur, we can hold down the effect of representativeness. Confirmation bias is the tendency to selectively search for and consider information that confirms one's beliefs. So we spend some time challenging people's beliefs. We give them 3 days to get the facts and to share ideas with one another and then to consider other perspectives. A framing effect is another heuristic. People often react differently to a choice depending on whether the outcomes are presented as a loss or as a gain. So positive versus negative framing is important. We could ask, how well does something work, or how often does it fail? And those differences in questions can affect the way people answer. So we ask them to not automatically accept the initial framing, and we might discuss different frames when we ask the questions. We're striving for objective, neutral framing when we pose our questions. And we do ask if a different frame would change their thinking. We encourage them to challenge other people's framings as well. So the challenge for them was to fight against relying on these heuristics.